Well, hello again, everyone. Mr. Reeves back with you as we continue working our way through solving systems of linear equations by substitution. Excuse me. So in the first video that I hope you got a chance to watch, we did a few problems. I think maybe it was just two problems actually. And I said we were going to find perhaps a couple more difficult examples. And then I went looking and realized there weren't really more difficult examples than what they had at this level. So I decided instead to go ahead and dive into some examples off IXL because they start off at least a little bit differently, and I thought you might be a little bit confused. So if you take a look at this first example, we have a system of equations. And again, we are looking to find the value of x and y that's going to make both equations true. All right, but they've made it really easy for us here. Do you know why? Because what do they say in that first equation? They say x is equal to -10. And I showed you in that other video that whatever x is equal to in the first equation is what x has to equal in the second equation. So if x equals -10 in the first equation, then I'm going to take this -10 and I'm going to put it right there for x. So I'm going to go to my second equation, which says 6 times x, but I'm not going to put x. I'm going to put what x is equal to in the first equation, -10 plus 8y equals -12. So again, if I do my color coding that I love to do so much, right here I've got this 6, and that's that 6 right there, and I've got the plus 8y equals -12. I've got the plus 8y equals -12. The only thing that changed was that x equals -10. Whoa, I wanted some blue. Let's try this again. Blue, blue, blue. That -10 there is now right there, right? I replaced that there. So now the great thing about substitution is you go from two equations, right, with two variables, to now we just have what? One equation with one variable. And you see how great that is? Because now we can solve this equation. 6 times -10 is -60 plus 8y equals -12. How do we solve equations in one variable? We use inverse operations to get that variable by itself. I'm going to go ahead and add 60, and I get 8y equals 60 take away 12 is 48. I divide by 8, and I get y is equal to 6. Awesome. So now I know that y is equal to 6. So I can go over here, making sure I'm in the y spot, and put 6. And now normally we'd have to go back and find the other variable, but guess what? We already know the other variable. X is -10. So I'm going to go ahead and put that value in there. I'm going to hit submit, and ka-chow. We're good, right? All right. So if you look at this one right here, they didn't give us what x was. They gave us what y was, right? Y is equal to 4. So if y is equal to 4 in the second equation, I'm going to take that and I'm going to put it right there, right? Right there for that y right there. So I'm going to go 7x plus 3y equals, whoa, no, Mr. Reeves. I'm not going to put 3y. I'm going to put 3 times 4 because now I know that y is 4, right? Equals -16. So I get 7x plus 12 equals -16. All right, so once again, if you take a look right here, I had this top equation. I had 7x plus 3. There's 7x plus 3. There's the equal -16. There's the equal -16. But what did I do? I took out this y right here, and I replaced it with what y was equal to. Y is equal to 4. And again, that took me from two equations with two variables to one equation with one variable, which now I can go ahead and solve using inverse operations. The opposite or inverse of adding 12 is going to be subtracting 12. 7x equals -28. I divide by 7, and I get x is what? -4, right? So I can go over here and remembering to put it in the right spot, we found x is -4. Then normally I'd have to go back and find out what y is, but guess what? They already told me what y is. Y is 4 in the bottom equation, which means y was 4 in the top equation, and we got it. All right, so enough of these easier problems. Let's go ahead and skip to the next level. Here we go. Okay, y equals 5x minus 2 and y equals 9x minus 10. Now this one looks a little bit different. And I got to tell you, students often have difficulties with these ones. And I always kind of wonder why. But there's got to be something about it. And that's not a pun, by the way, wondering why. Never mind. All right, so the first y, right? What does that first y equal? Y equals 5x minus 2. And the second y equals 9x minus 10. But remember, this is just like the other ones. Whatever the first y is, the second y is, or whatever the second y is, the first y is. So I'm just going to go ahead and say that first y equals 5x minus 2. So what am I going to do? I'm going to put it right there, right? So I'm going to go to my second equation, but instead of y, what am I going to put? I'm going to put 5x minus 2 equals 9x minus 10. So again, all of this part right here equals 9x minus 10 equals 9. Ooh, it's a good thing I checked this. Equals 9x minus 10, not 9x minus 2. All right, that part's the same. What has changed? What has changed was I took out this y, and what did I put there? I put 5x minus 2, right? 5x minus 2. Now, I do get something a little bit different. I still went from two equations with two variables to one equation with one variable. But here's the big difference. Now I have variables on both sides. So it's a little bit different type of equation. All right, so what am I going to do? When you have variables on both sides, you need to get them on the same side. And if you've been paying attention to Mr. Reeves, he always recommends that you subtract this smaller value of the variable, in this case x, from the larger value, right? So I get -2 equals, last time I checked, 9x minus 5x was 4x. So -2x equals 4x minus 10. Now this one is looking good here. We got a two-step equation using inverse operations. I'm going to add 10 to both sides. I get 8 is equal to 4x. I'm going to divide by 4, and I'm going to get 2 is equal to x. All right, so what does that mean? That means x is equal to 2. Now, I need to find out what y is, right? So let's go back to where we were. All right, we have x is 2, but what is y? Now, in those previous problems we were looking at, they just told us what one of the variables was, and they kind of did. They said if you want to know what y is, you could do 5x minus 2, or if you want to know what y is, you could do 9x minus 10. And guess what? It doesn't matter which of these we do because we're finding the value of x and y that make both equations true, and I'm going to prove it to you. We know that x is equal to 2, right? That's what we got. So 5 times 2 minus 2. What's 5 times 2? 10. 10 minus 2 is 8. Let's do this one. 9 times 2 minus 10. Well, what's 9 times 2? 18. 18 minus 10 is 8. So either one, we get 8 is equal to y and 8 is equal to y. So guess what? 8 is equal to y right here. All right, that makes both equations true. So I'm going to go back in here. I'm going to type in 8 and ka-chow. We're good. All right, as you can see, this is just the same type of problem. So I'm going to be doing the same thing. All right, this time though, I'll tell you what, I'm going to just go ahead and slide this one up there just to show you could put the top one into the bottom one just as easily. And I get 7x plus 1. Excuse me, 7x plus 1 is equal to 4x minus 2. Here we go. Variables on both sides. I'm going to subtract the smaller from the larger, and I get 3x plus 1 is equal to negative 2. All right, here we go. Minus 1, minus 1. 3x equals negative 3. Divide by 3, what do I get? X equals negative 1. X equals negative 1. But what is y? Well, we got two equations we could use, right? Again, we have y equals 4x minus 2. Or we have y equals 7x plus 1. And from the previous example, we know it doesn't matter which one we do. How about we do the second one? 7 times negative 1 plus 1. What do we get? Negative 7 plus 1 is negative 6. So we get negative 1, negative 6. And if you didn't believe me, I'm going to prove it to you. What is 4 times negative 1? Negative 4 take away 2. What do we get? We also get negative 6. So negative 1, negative 6 is the answer that we want right here. Negative 1, negative 6, we go. And man, we're good. Look at that. We're all the way up to 86. We are proficient without even doing a hard one, but I want to skip up to the next level. Ooh, the challenge zone. By the way, you need to be able to do these ones in the challenge zone. Even though IXL is calling them the challenge zone, I don't consider this really in the challenge zone. Okay, what makes it harder? Because we don't have an equation that says x equals or y equals. All right, so see though right there, do you see how that y has an exponent, not an exponent, excuse me, a coefficient of 1? You don't see it there? So do you remember what the previous video said? It said you want to get that variable by itself. Just like the examples we were doing, we want an equation that says y equals. So I'm going to go over here and I have negative 3x plus y equals negative 18, and my goal is to get that y by itself. So what am I going to do? I'm going to add 3x to both sides, and when I do that, I get y equals 3x minus 18. All right, do you see how this is better now? Because now I have an equation that tells me what y is. So I'm going to take this, gosh, it's way far away, but I'm going to move it, woo, 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 right there, right? So I got this. This was my second equation, right? This is my second equation, and this is my first equation. So I'm replacing the y from the second equation into the first equation. All right, so my first equation is 4x minus 6, but instead of y, what am I going to put? I'm going to put 3x minus 18. 3x minus 18 equals negative 18. All right, 4x. So again, just to show you what I'm doing, here's my first equation. There's the 4x minus 6. There's the 4x minus 6. There's the equal negative 18. There's the equal negative 18. But what did I do? I took out that y and I put what y was equal to from the second equation. In the second equation, y equals negative 3x minus 18. So I put that into my first equation. All right, now, again, this is a little more complicated. I'm going to have to apply the distributive property. And when I do so, let's see what I get. I get 4x minus 18x plus, all right, 6 times 18. Well, if you don't know what 6 times 18 is, maybe you're going to reach for your calculator, which I should have had open, but I didn't, so I apologize for this slight delay. Let's go ahead also and hide the press key. What were we trying to do? 6 times 18. I probably could have done it by hand while I was waiting for that, and I get 108. Just wanted to let you know it is okay to grab the calculator sometimes. Don't do it for the easier problems, but you know, be smart about it. So here we go. 4 minus 18. All right. Well, if you have 4 and you take away 18, now you're at negative 14 plus 108 equals negative 18. All right. Now, again, we have this nice two-step equation. We're going to do the inverse operation. We're going to subtract 108 from each side. We're going to get negative 14x equals negative, what is that, 126, right? Negative 108 plus 18, 8 plus 8 is 16. I'm going to divide by negative 14. All right, I'm thinking 10 would be 180, right? I mean 140, right? So it's going to be 9, but let's say you didn't know that. We could go ahead and reach for our calculator, and we could do a negative 126 divided by a negative 14, and when we do that, we get positive 9. Look at that, your math teacher was right. So x is equal to 9, right? And if we want to know what y is, let's go to our equation that says y equals, right? So y equals 3 times 9 minus 18. Y equals 27 minus 18, and 27 minus 18 is 9. No way, is that allowed where they're both 9? I'm thinking I'm going to live on the edge here and just see if I'm right. I'm going to put it in 9, 9, cross my fingers, and I got it. Alrighty, so I'm not going to do this last one all the way, but I just want to remind you when you're looking and you're deciding which variable to solve for, if at all possible, look for the one that has that coefficient of 1. So for this one, if I had negative x or the opposite of x plus y equals negative 9, I'd go ahead and add x to both sides. That's going to get me y equals negative 9 plus x, or I think I'll write x minus 9, right? Then I'm in good shape. I'm going to put this in for that y, and then I'd go from there. But I'm going to let you do that on your own. Ladies and gentlemen, that is our second video. Probably could have been our first one, but hey, hindsight's 2020. So in our last video on solving equations by substitution, we're going to do some problem solving. All right? Thanks for watching. Hope you have a great day.